Hello, everybody, and welcome to the Firmo webinar. We're sitting today with our co-CTOs, Guri and Ariel, who are going to answer some of the questions you guys have submitted around ERC20. In case you don't already know, Firmo is building the future for smart financial contracts within the crypto economy. So we have a programming language we made called Firmo that's formally verified and domain specific. And some of you have been asking us questions in and around the ERC20 standard and how that works. So we'll get started right away and jump in and ask you guys, what is ERC20?
Hi, everyone.
Hello.
Hello.
You want to answer? Or?
No, maybe you talk.
I guess you can say which one's Guri and which one's Ariel. Maybe we should.
I'm Ariel.
I'm Guri. Hi.
And the Firmo guy is Guri.
Yeah.
So ERC in general stands for Ethereum Request for Comment, which is basically a recommendation for the Ethereum community on how to use smart contracts. When you write smart contracts, it's a recommendation how to use it. ERC20 is the request number 20 that was made on this network, and it's talking about a recommendation on how to write a smart contract that manages a token underneath it. Okay. So it's like an API, it's like an interface, which it's the recommended interface by the community to implement, so that it would be easy to interact with your token. And for example, exchanges can more easily integrate with it without needing to know the inner details of your specific token. You just implement the same interface, and everybody implements on their side something that uses that interface. There's another thing called EIP, which stands for Ethereum Improvement Proposal, and that's similar to ERC, but that's for proposing improvements on Ethereum itself, and not like, for example, another ERC can be a recommendation on how to spell variables when you write a smart contract. And EIP would be a recommendation to the Ethereum core team to, for example, adopt a proof of stake instead of proof of work, which is a conceptual change in Ethereum itself, not for smart contracts.
I think there's kind of a key question here too, though, which is why is there an ERC20 standard?
Well, I think Ariel explained that quite clear, that basically once you adhere to this interface, you make it easy for the large exchanges to implement your token. So like to connect with your token and to let other people trade on it. So it started as a recommendation, but basically all of Ethereum's token are based on ERC20. And this is what makes it very easy to communicate with.
So for example, if Binance has they have at least a dozen ERC20 tokens supported in their platform, if you, for example, write your own token and you want to be adopted by such exchanges, it will be much easier for them to adopt your product, especially when they don't know the upside from their side. They don't know how much they'll really earn and how big of a project you're going to be. They want a minimal amount of work in order to integrate with you. And if they have already someone that has implemented the same interface, it's like a no-brainer for them.
Yeah, that makes a lot of sense. One of the questions we had submitted from the Firmo Telegram community group was, what are the security problems with ERC20, the ERC20 standard?
That's a very broad question. So I'll try to answer. I hope I'm answering whatever whoever asked it meant to talk about. But basically, there are a few things. First of all, as with any program, when you have bugs in Ethereum, it might be a big issue. Now, the big things that you need to be aware of when writing ERC20 tokens is especially overflow bugs. So you especially need to pay attention to that and use safe math libraries which assert and throw exceptions when there's an overflow bug. And an overflow rug is a case in which someone tries to play with your contracts and send too big or too small of a number to cause an overflow, which is a situation in which the arithmetic operation actually exceeds the amount of information which can be stored in the numerical variable. So that's one thing. Another important thing about ERC20 contract is that a lot of them are implemented not according to the actual requirement, to the actual interface, the ERC20. For example, the Open Zeppelin implementation, they have like they have a different approach. That when there's a problem, they actually throw an exception when the ERC20 standard actually says that you need to return a false answer. Now, by throwing an exception, what they do is they actually stop the flow of things, and they might get into a situation where one user is accredited for the amount and the other user is not. And especially there is a problem where you send out, for example, a good example of that is if you send money to an address that doesn't exist. So if you send in the ERC20 world, or let's start from the Ethereum world, when you try to send out Ethereum to some bogus address which doesn't exist, it won't work. And when you try to send out money to a contract, for example, that is not meant to receive Ethereum, it will also be rejected. So you can't send Ethereum to someone that is not intended to accept Ethereum. Only someone that is agreeing to accept Ethereum will accept Ethereum. With tokens, you have the risk of sending money to someone that is not willing to accept that token, and therefore will not be able to retrieve that token later on. For example, a huge issue with ERC20 is people sending money when there's an ICO. People sometimes send money by mistake to the contract. For various reasons, copy and paste mistakes, various reasons, they send money to the contract itself, and the contract is not an entity that was meant to hold these tokens, and there's no mechanism even for the developer of the contract to later on release these locked tokens. So it's actually tokens that are accredited to an account which won't ever use them, and they're lost. And there are millions of dollars worth of tokens lost in this way. In EOS, for example, alone, there are like I might be mistaken with the number, but I remember $4 million locked in such tokens on the contract address, and it's really easy. You can use the Etherscan and use the crowd sale contracts and see that. It's huge numbers. So I hope I answered. There are a lot of more aspects in securities, like such a broad aspect.
Sorry.
Yeah.
Maybe I just add one comment that in general, when you use Ethereum, which holds the ERC20 standard, code is law. Like that's the motto. So that I think that's like the basic biggest security issue. Like you can't easily deploy a fix. You're out there, you're vulnerable, you probably get hacked and destroyed. That would probably what will happen if you remember the DAO hack. If you read into that story, which is like very nice story, you will read that the first third of the total amount was grabbed by the hacker, and the other 2/3 were grabbed by white hat hackers, using the same vulnerability, because that was the quickest way to make it secure, to use the vulnerability and to move it like by yourself to someplace safer, because it's so very hard to upgrade.
There's no quick fix. You can't like find a bug. Okay, there's a bug and fix it, and an hour later there isn't that bug. You need time to test, to deploy, to migrate all the data from one contract to the other. So that's what I think Gori is referring to.
Like when there is a security issue with regular piece of software, you usually can really quickly turn it around. Like 24 hours later, you have a patch of some sort. Even if it's like OS level, it happens. It will just take additional 24 hours. In this case, you don't have such solutions. It will cost a lot and it will take a lot of time. So I think that's like the biggest issue related to security.
We have a nice Medium post covering these different hacks and the vulnerabilities in smart contracts too, which we can link to later. But yeah, it's exactly what you're talking about. And I think code is law is a really good takeaway from that front. The next question we have is, what are other standards that someone who's creating smart contracts should be looking out for? So right now, ERC20 is kind of the big one people are talking about, but what's on your radar or other things people should be aware of? You kind of mentioned it in the beginning.
Yeah, so there are a few, but there is not like a big one. There's ERC871, which is 829.
Fungible and non-fungible.
Yeah,
are you talking about Ethereum worlds only, or are we talking about, because the question was in like smart contracts in general?
Yeah,
so
you need to understand also that ERC is not just for tokens. I mean, most of the ERC numberings are for requests for comments for other issues, and the amount of requests for improving ERC are just a few. None of them were really adopted by any of them. I know that 871, I think, is already implemented by OpenZeppelin. There is 721, which is actually interesting. It's a fungible token, so it means that in regular ERC20 tokens, all the tokens are the same. So you don't have ownership of a certain token. The ERC20 is actually just a balance sheet holding all the balances of all the different accounts, and the balance changes according to the transactions that you do. In ERC720,
the guy is asking, what is the main difference for the different ERC standards? And if you can kind of say, how do I know which one to pick if I'm going ahead and starting to make smart contracts? What should I do, whether it's the fungible or something else?
So again, smart contracts, you have a lot of different smart contracts. ERC20 or ERC721 or whatever, they're ERCs that are recommendations for how to write a smart contracts for managing a token. That's just a number of it's not a lot of contracts that do exactly specifically that task. So if you're going out and you're writing a smart contract in general, you need to adhere to like recommendations made by the community, regardless of ERC20. If you're going to write a token, there is no go to ERC other than ERC20 right now. If you're going to go on a different approach, and we actually consider that, and there is, for example, ERC, what is it called? 892 is basically allows you to attach data to transactions, which was beneficial for us in our implementations. But we eventually decided to not experiment ourselves with these, and especially not risk ourselves with hard integrations with exchanges later on. So if you're going on with writing a token on top of the Ethereum network, I would highly suggest you go with ERC20. There is only, I think, one example of a token that deviated from that, and it cost them a lot. So I won't recommend like deviating from in that aspect. You can implement your ERC20 in lots of different ways, enhance it from your end. But again, take into consideration that any enhancement that you add on top of ERC20, even though it's just an enhancement, it adds the risk that you break the basic ERC20, the basic ERC20 logic, the basic implementation. Because if you're going with a simple ERC20, you can use OpenZeppelin or a known contract and have audited code with very minimal risk. If you're going on an adventure of implementing something your own, you're again exposing yourselves to unnecessary risks and costs if you want to audit it yourself.
True.
All right. The last question we have is, can I create a smart contract that interacts with an ERC20 contract?
Sorry, again?
Can I create a smart contract that interacts with an ERC20 contract?
Yeah, I mean, it depends what you want exactly to do. If it's two contracts right now that you wrote, then it's basically it's a no-brainer. You can
just a model.
Yeah, you can just integrate them. But basically, if you want a smart contract to interact with a token smart contract, you basically need the smart contract to have Ethereum in its balance, so it can spend on transaction and gas costs. Because any transaction it does with the token contract will actually cost. It's as a user. It will cost tokens.
Usually, a user calls an API function on an ERC20 token, and the user pays for that gas because he's running something on the big machine.
The other approach, that's one approach, and the other approach is to actually call the smart contract of the token in a way that would reflect the gas cost back to the original caller of the function. So, for example, if a caller calls a function that later on utilizes a token contract, then the gas cost can be applied to the original user if you want. But anyway, the point is that you'll have gas costs. If you use an external contract, you have gas costs.
Yeah, and we talked about that in last week's webinar as well, how gas cost works and what you need to think of when you're incorporating that into your smart contract. Very cool. Do you have any last comments you guys want to add on this, or tips or advice for people that are getting into ERC20 and trying to wrap their heads around it?
I think in general, if you get into ERC20, just read a lot of Stack Overflow, read a lot of Open Zeppelin code. The most famous contracts are out there. You can read, like, they are installed on the Ethereum network and they are open for everyone usually. Like, they're usually very readable and you can just have a look and learn from that. And
when you say the most famous contracts, which ones are you referring to? Just in case somebody.
For instance, we've looked into Bancor's contracts. You can look into like every ERC20 contract. You can just check out.
Yeah, especially if what you need to look out for is the traits that you want your contract to have. For example, if you want the token to be mintable, if you want someone to be able to mint that token and create more tokens, or you want the tokens to be pre-allocated all from the get-go and just spread out later on by the owner of the contract. There are burnable contracts which allow you to burn, like there is a certain address that is allowed to burn tokens and increase the scarcity of the token. There are a lot of different models for writing a smart contract, a token smart contract, ERC21. So even within the ERC20 standard, there is a lot of flexibility of how your contract behaves. So that's something you need to take into consideration. And again, as Guri mentioned, if you go into Open Zeppelin, you have a vast amount of examples and base tokens which you can refer to and base your token on and write all the things that I just talked about are actually things that you have for free from Open Zeppelin.
Plus, I think it's a good suggestion to start doing it early on because it will affect the business model quite fast. Like once you go through the entire list of the approaches to build a token and you get like a better grasp of how it's usually being done, it quickly, you go back to the product and quickly affects like how the product proceeds because it sets like how you can do it. So do that early on and start getting the learning curve because it's quite huge.
So what would you say step one is in terms of all of this before you get to the product if you're on the technical side and trying to build this?
Usually, like step one is really like not defined really well usually because you're just starting out. So I would just say read a lot, like get as much information as you can and it gets like it takes form with time. Like after, I don't know, 1 week or 2 weeks, you get some kind of grasp of how stuff works in this like context, and immediately you have input for the product.
Look at examples. Just look at different examples. Think what you're looking in for in your token, and then look for examples that implement similar interfaces. And there is not a lot of permutation, so I like there's not like endless amounts of token models, and it's all small variations on the base few that there are out there. So it's not like a big effort to just go out and learn the different ERC20 variations.
I think the setup is the big issue. Like if it was a regular language in a regular context running on like your PC, we wouldn't be having this conversation. Like the security issues with having like a bug in your crowd sale contract, for instance, or something like that, it's usually means you lose everything and that's it, the end of story. If it was just like a .NET application, you would just debug it and then patch it and that's it, like nothing, no biggie, but the risk is the huge thing here.
Yeah, especially with the token contracts, you simply can't afford any bug. Like you need to take into consideration that a smart contract that deals with tokens is very simple. It's not rocket science. It's very simple. It's at most like 100 lines of code, and it needs to be solid. There's no room for fancy tricks, programming tricks. It needs to be simple code that works with absolutely zero bugs.
Perfect. Thank you for today, guys, and we'll be back next week with a new topic and some more questions.
Thank you, Annalisa.
Bye.
Bye-bye.